Introduction to Programming Fundamentals, the Complete Masterclass. Part 1, The Beginner's Foundation. Module 1, Introduction to Programming Fundamentals. This module lays the groundwork for programming, covering essential concepts like code structure, data storage, and reusable blocks of code.
Lesson 1.1, Course Introduction and Setup. Welcome to the Introduction to Programming Fundamentals. Before we can write code, we need a place to write it and a way to see what it does. Think of it like cooking. Before you can make a meal, you need a kitchen with a cutting board and a stove. For us, our cutting board is a code editor, and our stove is the browser's console, where we can see the output of our work. Our learning objective for this lesson is to understand the course structure and set up the basic environment needed for programming. We will install a code editor and learn how to run a simple Hello World program to confirm everything is working correctly. Let's begin. The first step is to install a code editor. A popular and free choice is Visual Studio Code. Once installed, you can open it and create a new file. In this file, you can write your very first line of code. For example, in JavaScript, you would type console.log hello world. To run this, you can open a web browser, open the developer tools, and paste this line into the console. You should see the message, Hello World, printed back to you. This confirms your setup is complete and you're ready to start programming. Now, let's test your understanding. The main goal of this lesson was to get your environment ready. To confirm your success, your task is to run a simple Hello World script in your console. If you see that message appear, you have successfully achieved our objective.
Lesson 1.2, Commenting and Code Readability. When you write code, you're not just writing instructions for the computer, you're also writing for other humans, including your future self. 6 months from now, you might not remember why you wrote a complex piece of logic. Comments are notes you leave in your code that the computer ignores but are invaluable for humans. They are the signposts that make your code readable and maintainable. The learning objective is to explain the purpose of comments in code and apply best practices for writing clear, maintainable comments. We will cover 2 types of comments, single line and multi-line. In most programming languages, you can write a single line comment by starting the line with 2 forward slashes. Anything after the slashes on that line is ignored. For longer explanations, you can use a multi-line comment, which typically starts with a slash and an asterisk and ends with an asterisk and a slash. Anything between these markers is a comment. Good comments don't state the obvious, like saying x equals 5 / sets x to 5. Instead, they explain the why. For instance, x equals 5 / set the maximum number of retries. This provides context that the code alone cannot. For your activity, take a small snippet of code. Your task is to add both single-line and multi-line comments to explain its purpose and functionality to another developer. To assess your understanding, review a new code sample. Can you identify areas where comments could improve readability? Explain what kind of comment you would add and why it would be helpful. A good answer would point out complex or non-obvious parts of the code and suggest comments that clarify the intent behind them.
Lesson 1.3, Variables, Declaration, Assignment, and Usage. Imagine you need to remember a piece of information, like a phone number. You might write it down on a sticky note and label it John's number. In programming, a variable is that sticky note. It's a named container where you can store a value to use later. Instead of retyping the value everywhere, you just refer to it by its name.
The learning objective is to define what a variable is, declare variables, assign them values, and retrieve their contents. We will learn how to create variables to hold different types of data, such as numbers, text, and true or false values. To declare a variable in JavaScript, you use a keyword like let, followed by the name you want to give the variable. For example, let user age, semicolon. This creates a container named user age. To put a value into it, you use the equal sign, which is the assignment operator. So user age equals 30 stores the number 30 in the user age variable. You can also do this in one step. Let username equals Alice. Now, whenever you use username in your code, the program will see the value Alice. For your activity, declare 3 different variables. One should hold a number, one should hold a string of text, and one should hold a Boolean, which is a value that is either true or false. Then print the value of each variable to the console. For your assessment, write a short script. It should declare 3 variables, one for a first name, one for a last name, and one for an age. Assign your own information to them, then display a sentence that uses these variables, such as, "My name is John Doe, and I am 42 years old."
Lesson 1.4. Functions, definition, calling, and parameters. Imagine you have a task you need to do over and over again, like making a sandwich. You wouldn't relearn the steps every time. You'd have a recipe. A function in programming is like a recipe. It's a reusable block of code that performs a specific task. You define it once, and then you can call it whenever you need to perform that task. Our learning objective is to define a function, understand its purpose, call a function, and pass arguments through parameters. To define a function, you use the function keyword, followed by a name for the function, a set of parentheses, and then curly braces that contain the code for the task. For example, function say hello, console.log hello. This defines a function named say hello. To run it, you call it by typing its name followed by parentheses. Say hello, parentheses. Functions become even more powerful when you can give them information to work with. These pieces of information are called parameters. You define them inside the parentheses when you create the function. For example, function greet name console.log hello plus name. Now, when you call the function, you provide a value called an argument for that parameter, greet Bob. This will print hello Bob. Your activity is to create a function that takes 2 numbers as parameters and prints their sum. Then call this function with at least 2 different pairs of numbers to see the different results. For your assessment, write a function that accepts a name as a parameter and returns a greeting message that includes that name. For instance, if you pass it the name Maria, it should produce the string hello Maria.
Lesson 1.5. Return statements in functions. So far, our functions have only printed messages to the console. But what if we want a function to perform a calculation and give us back the results so we can use it somewhere else? This is the job of the return statement. A return statement stops the execution of a function and sends a value back to whoever called it. It's like asking a friend for a calculation. Their answer is the return value. The learning objective is to explain the role of the return statement in functions and use it to output values. Inside a function, the return keyword followed by a value will exit the function and pass that value back to whoever called it. For example, consider this function. Function add AB return A plus B. This function doesn't print anything. It simply calculates the sum and returns it. To use the result, you must store it in a variable. Let sum equals add 5, 3. Now the variable sum holds the value 8, and you can use it in other parts of your code. For your activity, modify the function you created in the previous lesson.
Instead of printing the sum of two numbers, make it return the sum. Then, create a variable to store the returned value and print that variable to the console. To assess your understanding, create a function that calculates the area of a rectangle. It should accept two parameters, width and height, and return the calculated area.
Lesson 1.6, Function Interaction and Scope. In a real application, functions don't work in isolation. They often need to work together, with one function calling another to perform a subtask. We also need to understand where our variables live. This concept is called scope. Some variables are global, meaning they can be seen from anywhere in the code. Others are local, trapped inside the function where they were created. The learning objective is to describe how functions can call other functions and differentiate between global and local variable scope. First, function interaction. One function can easily call another. For instance, you could have a calculate total function that calls a calculate tax function to help figure out the final price. This helps break down large problems into smaller, manageable pieces. Second, scope. A variable declared outside of any function is global. It's accessible everywhere. A variable declared inside a function is local to that function. It cannot be seen or used by any code outside of that function. This is a good thing. It prevents functions from accidentally interfering with each other's variables. For your activity, create two functions. The first function should call the second function. Then define one global variable and one local variable inside one of the functions. Try to access both variables from both inside and outside the function to see where you get an error. This will demonstrate the boundaries of scope. For your assessment, you will be given a code snippet that involves nested function calls and variables with different scopes. Your task is to predict the final output of the code without running it, explaining your reasoning based on which variables are accessible where.
Lesson 1.7, Basic Math Operations and Assignment Operators. At its core, a computer is a calculator. Program languages provide a set of operators to perform mathematical calculations, just like you would on a calculator. We also have shortcuts called assignment operators that make it easier to modify the value of a variable in place. Our learning objective is to perform basic arithmetic operations and utilize assignment operators for concise variable manipulation. The basic arithmetic operators are what you'd expect: plus for addition, minus for subtraction, asterisk for multiplication, and a / for division. There's also the modulo operator, represented by a %sign, which gives you the remainder of a division. Assignment operators are shortcuts. Instead of writing score equals score plus 10, semicolon, you can write score plus equals 10, semicolon. Both do the same thing. This works for all the basic math operations, such as minus equals, times equals, and so on. They make your code cleaner and easier to read. For your activity, write expressions using all the basic arithmetic operators: addition, subtraction, multiplication, division, and modulo. Then, rewrite some of these expressions using the compound assignment operators. For your assessment, you will be given a variable that starts with a certain value. A series of arithmetic and assignment operations will be performed on it. Your task is to calculate the final value of the variable after all the operations have been completed.
Module 2, Control Flow and Logic. This module introduces the fundamental concepts of control flow, allowing programs to make decisions and repeat actions based on conditions. Lesson 2.1, Conditional Logic, If and Else Statements. So far, our programs have run from top to bottom, executing every line. But real applications need to make decisions. For example, if a user is logged in, show them their profile page. Otherwise, show them the login page.
The if statement is the primary tool we use to create this conditional logic. The learning objective is to implement if and else statements to execute code blocks conditionally based on Boolean expressions. An if statement checks if a condition is true. If it is, the code block inside the if statement is executed. The condition must evaluate to a Boolean, true or false. For example, if age is greater than 18, console.log, access granted. You can also provide an alternative block of code to run if the condition is false. This is done with an else statement. So you could have, if age is greater than 18, then else, console.log, access denied. The code inside the else block will only run if the initial condition is false. For your activity, write a program that checks if a number is positive or negative. It should store a number in a variable, then use an if-else statement to print either the number is positive or the number is negative to the console. For your assessment, you will be given a scenario, such as determining a user's access level based on their age. Write an if-else statement that checks if the user's age is greater than or equal to 21 and prints the appropriate access message.
Lesson 2.2. Advanced Conditionals, Nested Statements and Booleans. Sometimes a single if statement isn't enough. We might need to check multiple conditions to make a decision. We can do this by nesting if statements inside one another, or by using logical operators like and or to create more complex Boolean expressions. Our learning objective is to construct nested if statements and utilize Boolean logic to create complex conditions. A nested if statement is an if statement inside another if statement. This allows you to check a second condition only if the first one was true. Logical operators provide a more elegant way to check multiple conditions. The AND operator, written as two ampersands, is true only if both conditions on either side of it are true. The OR operator, written as two vertical bars, is true if at least one of the conditions is true. The NOT operator, an exclamation mark, inverts a Boolean value. For example, to check if a user is an adult and a premium member, you could write if age greater than or equal to 18 and is premium member, then do something. For your activity, write a program that checks if a user is eligible for a discount. The criteria are that the user must be over 65 years old or be a student. Use logical operators to implement this logic in a single if statement. For your assessment, you will be given a complex Boolean expression involving and, or, and not. Evaluate the expression to determine if its final result is true or false and predict the outcome of a nested conditional block that uses this expression.
Lesson 2.3, Multi-Way Branching, Switch Statements. When you have a long series of if, else statements checking a single variable against multiple possible values, your code can get very cluttered. A switch statement is a cleaner, more readable alternative for these situations. It allows you to check a variable against a list of predefined values, or cases. The learning objective is to use switch statements as an alternative to multiple if statements for handling various discrete conditions. A switch statement takes a variable and compares its value to a series of case clauses. When it finds a matching case, it executes the code block for that case. It's very important to end each case block with a break keyword. If you forget it, the code will fall through and execute the next case as well, which is usually not what you want. You can also include a default case that will run if none of the other cases match. For your activity, create a program that takes a day of the week, represented as a number from 1 to 7, and prints the corresponding day name using a switch statement. For example, if the number is 1, it should print Sunday. For your assessment, you will be given a series of if statements. Your task is to convert this logic into an equivalent and more readable switch statement.
Lesson 2.4. Iteration, for loops. Repetition is a core concept in programming. If you need to perform an action a specific number of times, like sending an email to 100 users, you don't want to write the same code 100 times. A for loop is a control structure designed to repeat a block of code a fixed number of times. The learning objective is to implement for loops to repeat a block of code a specific number of times. A for loop has 3 parts inside its parentheses, separated by semicolons: the initialization, the condition, and the final expression. The initialization sets up a counter variable. The condition is checked before each repetition, and the loop continues as long as it's true. The final expression is executed after each repetition, usually to increment the counter. For example, for let I equal 0, I is less than 10, I++ will print the numbers from 0 to 9. The loop starts I at 0, runs as long as I is less than 10, and adds 1 to I after each run. Your activity is to write a for loop that prints the numbers from 1 to 10 to the console. For your assessment, write a for loop to calculate the sum of all numbers from 1 to 100. You'll need a variable outside the loop to keep track of the total, and inside the loop, you'll add the current counter value to your total.
Lesson 2.5. Iteration, while and do-while loops. A for loop is great when you know exactly how many times you want to loop. But what if you want to loop until a certain condition is met, and you don't know when that will be? For this, we use a while loop. It repeats a block of code as long as a given condition remains true. It is crucial to ensure that something inside the loop will eventually make the condition false. Otherwise, you'll create an infinite loop, which will crash your program. A variation is the do-while loop. The only difference is that the condition is checked after the code block is executed. This means a do-while loop is guaranteed to run at least once, even if its condition is false from the start. For your activity, create a while loop that continues to ask for user input until a specific word like stop is entered. Then create a simple do-while loop to see that it always executes at least once. For your assessment, explain a scenario where a while loop would be more appropriate than a for loop, and another scenario where a do-while loop would be the best choice. Provide a simple example for each.
Module 3. Data structures, objects, and arrays. This module delves into more complex data structures, allowing for the organization and manipulation of related data.
Lesson 3.1. Introduction to objects. So far, our variables have held single pieces of information, like one number or one string. But what if we want to represent something more complex, like a person who has a name, an age, and a city? An object is a data structure that allows us to group related data together using key-value pairs. The learning objective is to define an object, create objects, and access or modify their properties. An object is a collection of properties. Each property is a key, which is a string, and a value. You create an object using curly braces. For example, let person equals curly braces, name equals Alice, comma, age equals 30. Here, name and age are keys, and Alice and 30 are their corresponding values. To access a property of an object, you use dot notation. For example, person.name would give you the value Alice. You can also change the value of a property using assignment. Person.age equals 31. Your activity is to create an object that represents a car. It should have properties for its make, model, and year. Then access and print each of these properties to the console. For your assessment, create an object representing a book. Add properties for title, author, and publication year. Then write code to change the publication year and print a new value. Lesson 3.2. Object initializers and methods. Objects can store more than just simple data like numbers and strings. They can also store functions as values. When a function is a property of an object, It's called a method. This allows us to bundle data and the actions that can be performed on that data together. The learning objective is to understand object-literal syntax for creating objects and add methods as object properties. The syntax we've been using with curly braces is called object-literal syntax, and it's the most common way to create objects. To add a method, you define a property whose value is a function. For example, let person equals name equals Alice, comma, greet equals function console.log hello. Now you can call this method using dot notation, just like accessing a property, person.greet. Methods can also access other properties of the same object using the special keyword this. For example, the greet method could be written as console.log hello, my name is plus this.name. The this keyword refers to the object the method was called on. Your activity is to create an object, including a method that prints a greeting using one of the object's other properties. For instance, a dog object with a name property could have a bark method that prints woof, my name is Fido. For your assessment, add a method to the book object from the previous lesson. The method should be named getDescription, and it should return a string like The Great Gatsby by F. Scott Fitzgerald.
Lesson 3.3, Introduction to Arrays. Objects are great for storing key value pairs, but what if you just need an ordered list of items, like a to-do list or a list of usernames? For this, we use an array. An array is a special type of variable that can hold more than one value at a time, stored in a numbered sequence. Our learning objective is to define an array, create arrays, and access elements by their index. You create an array using square brackets, with the elements separated by commas. For example, let fruits equals apple, banana, cherry. The items in an array are ordered, and each item has a numbered position called an index. Importantly, array indexes start at 0, not 1. So in our fruits array, apple is at index 0, banana is at index 1, and cherry is at index 2. To access an element, you use the array's name followed by the index in square brackets. For example, fruits 0 would give you apple. Your activity is to create an array of your favorite movie titles. Then access and print the first, last, and a middle element from the array. For your assessment, create an array containing 5 numbers. Write the code to access and print the element at index 2.
Lesson 3.4, Array Properties and Basic Methods. Arrays come with built-in properties and methods that make them very powerful and easy to work with. These tools allow us to get information about the array, like its size, and to easily add or remove elements. The learning objective is to utilize common array properties like length and methods like push, pop, and join to manipulate array contents. The most common property is length, which tells you how many elements are in the array. For example, fruits.length would be 3. There are many useful methods. The push method adds a new element to the end of an array. The pop method removes the last element from an array. The join method creates a string from an array's elements separated by a character you specify. For your activity, create an array of numbers. Use push to add a new number to the end. Then use pop to remove the last element. Finally, use join to convert the array into a string where the numbers are separated by hyphens. For your assessment, you will be given an array. Write the sequence of commands to add a new element to the end, then remove that last element, and finally print the entire array as a comma-separated string.
Lesson 3.5, Advanced Array Manipulation, Sort, Reverse, and Iteration. Beyond adding and removing elements, we often need to reorder them or perform an action on every single element in the array. Arrays have built-in methods for sorting and reversing, and we can use the loops we learned earlier to iterate through them. The learning objective is to apply sort and reverse methods to reorder array elements and iterate through arrays using loops. The sort method sorts the elements of an array. By default, it sorts them alphabetically or lexicographically. Sorting numbers can sometimes require a bit more work, but for strings, it works as expected. The reverse method simply reverses the order of the elements in the array. To perform an action on every element, we can use a for loop. We can loop from index 0 up to the array's length -1. Inside the loop, we can access the element at the current index. For example, for I equals 0, I less than fruits.length, I++. This will print each fruit on a new line. Your activity is to create an array of numbers. Use the sort method to sort it in ascending order, then use a for loop to print each element of the sorted array. For your assessment, create an array of strings. Sort it alphabetically, then reverse the order so it's in reverse alphabetical order. Finally, use a loop to print each item on a new line.
Lesson 3.6. Associative arrays, objects as maps. In some programming languages, there's a special data structure called an associative array, or a map, which lets you use strings as indexes instead of numbers. In JavaScript, we achieve this functionality using objects. Using an object as a key value map is an extremely common and powerful pattern. The learning objective is to understand the concept of using objects as key value maps and how to access values by their string keys. While arrays use numbers as indexes, objects use strings as keys. Think of a dictionary. The word is the key, and the definition is the value. We can use an object to build a similar structure. For example, let capitals equals USA, Washington, D.C., France, Paris. To access the value, you can use dot notation if the key is a valid identifier, but a more flexible way is to use square bracket notation, similar to arrays. For example, capitals France would give you Paris. This is useful when your keys have spaces or special characters, or when the key is stored in another variable. Your activity is to create an object that maps country codes to country names. For example, the key US would map to the value United States. Then retrieve and print to country name for a specific code. For your assessment, you will be given an object representing a dictionary where words are keys and definitions are values. Write the code to retrieve the definition of a specific word using its key.
Module 4. Interacting with the environment and built-in objects. This module focuses on how programs interact with user actions and leverage built-in functionalities for common tasks. Lesson 4.1. Event handling. Static web pages are boring. Modern applications are interactive. They respond to user actions like clicks, key presses, and mouse movements. These actions are called events. Event handling is the process of writing code that listens for these events and runs a function in response. The learning objective is to explain what events are and implement basic event handlers to respond to user interactions, such as a button click. In web development, you can attach an event listener to an HTML element. This listener waits for a specific event to happen on that element. When it does, it executes a callback function that you provide. For example, you could select a button element from your HTML page and then add a click event listener to it. The function you provide would then run every time the user clicks that button. This is the foundation of all interactivity on the web.
For your activity, create a simple HTML file with a single button. Then write a script that attaches an event listener to this button. When the button is clicked, it should display a simple alert message. For your assessment, create an HTML paragraph element and a button. Write the JavaScript code to attach an event listener to the button so that when it's clicked, the text content of the paragraph element changes. Lesson 4.2, Built-in Math Object. Programming often involves mathematical calculations that go beyond basic arithmetic. Most languages provide a built-in math object that contains useful properties and methods for common mathematical tasks, like generating random numbers, rounding, or finding the maximum of two values. The learning objective is to utilize the built-in math object to perform common mathematical operations. The math object is not something you create, it's always available. It has methods like math.random, which gives you a random number between 0 and 1. Math.round rounds a decimal to the nearest integer. Math.floor always rounds down, and math.ceil always rounds up. Math.max takes multiple numbers as arguments and returns the largest one. These tools are incredibly useful for everything from games to data analysis. For your activity, write a script that generates a random whole number between 1 and 100. You'll need to use math.random and math.floor together to achieve this. For your assessment, write a function that takes two numbers as parameters and returns the larger of the two, using the math.max method. Lesson 4.3, Built-in Date Object. Working with dates and times is a common requirement in many applications. Logging events, scheduling tasks, or simply displaying the current date all require a way to represent and manipulate dates. Programming languages provide a built-in date object for this purpose. The learning objective is to create and manipulate date objects to work with dates and times. You can create a new date object to represent the current date and time. Once you have a date object, you can call various methods on it to get specific information. For example, .getFullYear will give you the 4-digit year. .getMonth will give you the month as a number from 0 to 11. And .getDay will give you the day of the month. There are similar methods for getting the hours, minutes, and seconds. For your activity, create a new date object for the current time. Then use its methods to extract and display the current year, month, and day. For your assessment, write a script that creates a date object and uses its methods to display the name of the current day of the week. For example, Monday.
Lesson 4.4, Working with Forms, Identification and Access. Forms are the primary way users input data into a web application. To make our applications useful, we need to be able to access the information that users type into form fields, like text boxes and dropdowns. JavaScript allows us to select these form elements and read their values. The learning objective is to identify HTML form elements and access their values using JavaScript. First, you give your HTML form elements, like an input tag, a unique ID. Then, in your JavaScript, you can use a method like document.getElementById to get a reference to that specific element. Once you have the element object, you can access its value property to read what the user has typed into it. This is typically done in response to an event, like the user clicking a Submit button. For your activity, create a simple HTML form with one text input field and a button. Write a script so that when the button is clicked, it accesses the value from the input field and displays it in an alert message. For your assessment, create a form with a text input and a Submit button. When the form is submitted, prevent the default page refresh and instead log the input's current value to the browser's console.
Lesson 4.5, Form Validation. Allowing users to submit any data they want can lead to errors and security issues. Before we process user input, we should always validate it to make sure it meets our requirements. This is called form validation. For example, we might check that a required field isn't empty, or that an email address looks like a valid email address. The learning objective is to implement basic client-side form validation to ensure user input meets specified criteria before submission. Client-side validation happens in the user's browser before the data is even sent to the server. It provides quick feedback to the user. You can use JavaScript to check the values of form fields when the user tries to submit the form. For example, you can check the length of an input field's value to see if it's 0. If it is, you can display an error message next to the field and prevent the form from being submitted. You can also check if a number is within a specific range or if a string matches a certain pattern. For your activity, add validation to the form from the previous lesson. The validation should check if the input field is empty. If it is, display an error message to the user. If it's not empty, then allow the submission. For your assessment, enhance the form validation to check a numeric input field. The validation should ensure the number entered is within a specific range, for example, between 1 and 100. Display an appropriate error message if the number is outside this range.